Hi everyone. In our last video, we created the outline for our contract, and in this video, we are going to start implementing our contract. First, we are going to implement the data section here. For that, we said that we are going to use counter, and we are going to use this from OpenZeppelin library. First, I'm going to create a new terminal here. Now, in this terminal, I'm going to say npm install OpenZeppelin contracts. What it does is, with this npm install, we are downloading the OpenZeppelin contracts library so that we can use it in our code. Now we downloaded it and we are going to import it at the top here. I'm going to say import OpenZeppelin contracts, and under the contracts I need utils. And under the utils, we have the contract called contracts.sol. So as you can see, we are getting an error. It says expected string literal or alias list. So if you are using IDE like Remix IDE, this way of importing is fine. But if you are having the same error as me, what you can do is you can say, I'm going to go 2 folders back, and there I have node modules, and under the node modules I'm using this library here, and this will fix our problem. After doing this, we are going to say using counters for counters.counter. This way we can use the functionality of the counters object. And below, I'm going to say counters.counter private counter. And this will be our counter object here. And I'm going to copy these and put them here under our counter section. Next, we are going to create our owner. For this, I'm going to say address private owner. And next, we are going to create our total payments. For that, I'm going to say uint private total payments. Next, we have our user struct. I'm going to say struct user, and inside this first we have the address field. We are going to say wallet address. Next, we have the name, the last name of the user, rented car ID. If this rented car ID variable of the user is 0, this means that the user did not rent any car. But if the ID is anything other than 0, then we would know user rented a car, and the rented car ID is the ID of the car the user rented. Next, we have balance. We have debt. We also have the start time. This start time will be in seconds, but once we are going to calculate the depth of the user, we are going to convert the seconds to the minutes. Next, I have my car struct here. First, I'm going to have my ID after I create my struct. I'm going to say ID here, name of the car, image URL of the car, status of the car. We also have the rent fee and the sale fee of the car. So here the status will be our status. It can be either retired, in use, or available. This functionality will be implemented down here in our enum. For this enum, I'm going to say enum status, and it can be retired, in use, or available. If our car is retired, no one can rent it. If it's in use, it means that someone rented this car and another person or another user cannot rent this. And if it's available, it can be rented by any user. Next, we are going to have our events, or our actions happening in our contract, so that our front end can know what's happening in our contract. First event we are going to have is car added event. For this, I'm going to say UID index ID. With index keyword, I'm saying that we can filter this event based on this ID. Next, we will have the name, image URL, rent fee, and sale fee. After this event, we have another event called car metadata edited. This should be metadata. And in this, again, we are going to have index ID, name, image URL, rent fee, and sale fee. After this, we have a separate event called car status edited. We have two different functions and two different events for editing cars because we may want to edit the car status much more than we want to edit car metadata. So by separating these functions, we are saying that we are going to use this function more, so the other sections of the car and the other code don't have to be executed for no reason over and over again. Next, we have the event, as we told, car status edited. And this we have our index ID and our status. Next, let's create an event called user edit, which will let us know we added a user. We are going to say address indexed, wallet address, name of the user, and last name of the user. After user edit, we have the deposit event. In this, we have the wallet address and amount. And the data type there. Next, we are going to have our checkout event. We are going to have indexed wallet address and indexed car ID. Next, we have a similar event for our check-in function where users return their car. We are going to have address, indexed, wallet address, and also indexed car ID. We are saying index in both cases because we may want to filter out based on the wallet address or the car ID. After the check-in, we have payments made method. For that, we are going to say wallet address and the amount of the payment. And finally, our last event is balance withdrawn. Here I'm going to say address, indexed, wallet address, and amount. Now we have our events here based on what we are going to have in our execute functions. And now we are going to create our mappings. Our first mapping is user mapping. It should be from address to user. It's going to be a private mapping and we are going to call it users. Next, we have our car mapping. It's going to be u into car so that we are associating IDs with cars here. It's also going to be private and we are going to call it cars. Next, we have our constructor. we will have no parameters here, and we are going to set owner to the message.sender in our constructor. So whoever creates the contract, whoever calls this constructor function, which is called when we create the contract, we are going to set the owner address of the address that the function caller. And then we are going to initialize our total payments to 0 here. And then we have our modifier. Our modifier is called only owner, and we are going to check here if our message.sender equals to the owner. If not, we are going to say only the owner can call this function. And then we are going to say continue. So what's happening with our modifier here, once we add this keyword only owner for our functions, what's going to happen is that our modifier will run, and then it's going to run the first line, which says require message.owner equals owner. With this time we are going to check if the message.sender is the owner, and then with this part our function code will come here. So basically we are modifying our functions every time when we set only owner. In our next video, we are going to start implementing our execute functions. Thank you.